Hey everyone, it's Mr. D. I'm here to cover the final exam review. For those of you who are tuning in who are not part of my class, this is just an overall review of basic algebra going from operations with integers all the way up to absolute value equations and inequalities. So with that, let's go ahead and get started. So in this expression here, the first thing you want to do is you want to go ahead and take these two, make them into a plus because you have the opposite of a negative, which is a positive. And then you get 8 plus 7, which is 15. And that would be the answer to that. You want to be careful not to confuse this with multiplication. It would not be 8 times positive 7. It would be 8 plus 7. Okay, moving on, number 2. So in this one, this is just a simple division of a negative value with a positive value, and I always like to refer back to these symbols here like this. It kind of looks like the Pringles face a little bit, but the way this works is, if you've never seen it before, is you look at the sign of your integers, and you can see that we have a negative and we have here a positive. Though it doesn't say plus, you can imagine there being a plus sign right there. So what you do with this face is you cover the signs of each integer. You cover that from the face. So I have a negative 49, I cover a negative. I have a positive 7, I cover the positive. And what you still see is the sign of the answer. Now you can see I have a negative left. And so what I get is I get a negative 7. So this whole thing simply becomes a negative 7. Okay, easy as that. By the way, just a little note for you. This face only works when you are multiplying and dividing, okay? Only when you're doing this or when you're doing this operation. It does not work when you're adding or subtracting, okay? So please try not to confuse it. When you're doing this and this, it does not work for that. Okay, so please be aware of that. It is often a pitfall among students to confuse it with that operation, and it's not. Let's go on to number 3. Number 3 is just multiplication, and if you remember anything about what you just saw a moment ago using that face, you'll know that if you were to redraw it, you would then have to conceal the two negatives. So that would leave a positive. And so the answer is simply positive 15. Okay, again, try not to confuse this with addition. This is not negative 3 minus 5, it's negative 3 times a 5. Moving on, number 4. I like this question because it involves a lot of careful manipulation of integers. And so what you do is you want to take the negative 8 and the negative 7, and you want to replace each of the letters you see here with their values from the right side. So what you get when you do that is the following. You get this. So this would be a negative 7 minus, now your Q is a negative value itself. See, it's negative 8. So when you place that all the way over here, you have to keep in mind there's already a negative sign right there. So that negative is here. And so I need to bring that down. Getting rid of all this, I get negative 8, minus, then I have negative 5, plus, and my value, my Q is a negative 8, so I'm going to put that in parentheses like this, and I'll put the power of 2 on the outside, and I'll wrap the whole thing up with another parentheses. And it's okay to do that. There's nothing wrong with putting double parentheses on things. What you want to do from there is take the double negatives, which are here, and turn them into a positive. Now, I don't recommend doing that here because you want to go by the order of operations, which says do whatever's inside parentheses first. And so we're going to handle whatever is in here on its own and then handle this negative outside later, okay? So doing one thing at a time. What I get now is I get negative 7 plus 8 minus still negative 5, and negative 8 to the second power is positive 64. That's going to go here, plus 64. Okay, and so I go back inside the parentheses and I will combine everything you see in there, you have to combine all that, and what you get is you get a 59. Now you could wrap this in parentheses or leave it outside parentheses, but I'm leaving it in there for now. The -7 minus 8, this right here, that becomes a 1, and now you have 1 minus 59. 1 minus 59 is -58, and that becomes the final answer. Okay, just like that. All right, number 5. So here we have an equation where you need to not only solve it, but you have to justify your steps and check the answer to see if it's correct. So the steps to doing this can be many, but if you are careful with how you do it, it's really not too bad. So the first thing I'd like to do is I always like to divide this down because your brain sees left side, right side, and it's easier to handle each part on its own. And then what I like to do is, or what you should do, is distribute the -4 inside. So we get -4k. And then -4 times -2 is +8. On the right side, you distribute the -2, and we get -2k. And -2 times -5, +10. Now, the goal of this is to join the variables k on one side. Now, when you're doing equations, it doesn't matter which side it ends up on, because the equality means that the left side and right side should mean the same thing anyway. But because inequalities usually follows equations, it's a good idea to form a habit of moving everything to the left side. So I'm going to do that by adding 2k, since that's the inverse of -2k. And I'll repeat that over here. Now what happens is these 2k's disappear, and on the left side I end up with a -2k. So -2k plus 8. And on the right side I have just 10. Now this 8 has to move to the other side, and the reason I want to do that is because I've decided on what side the k's are going to end up. They're going to end up on the left side, therefore I move all the numbers to the right side. So this is reverse order of operations, or reverse PEMDAS. So the inverse of addition is subtraction. This is a subtraction property. That goes away, and I get -2k is equal to +2. I'm going to move this over there, and I'm going to continue here. So -2k is equal to +2. What you do at this point is you go ahead and divide both sides by a -2. So dividing here by -2 is the opposite of multiplication, and multiplication is exactly what is holding these two things together. You can see the little multiplication dot was hiding there the whole time and you missed it. But you didn't see that, did you? But it was there the whole time. And the way to undo multiplication is always by division. Okay, so I don't want to divide by +2. I want to divide by whatever number is multiplying against my variable. So that would be a -2, divide by -2. My answer here is a -1. And the reason for that would be the same as what I said earlier. Going back to this face over here, you can see, going back to the face over here, you can see that you get a negative when you have a negative divided by a positive. Okay, taking it back over here. Now we are at the point where we need to explain each step that happened to go from beginning to end. An easy way to do this would be to simply look at whatever was done in green, and to be completely correct, I should go back to the beginning, and I'm going to mark these in green because this was the very first thing we did. So the first thing we did was we used the distribution property, or the distributive property. So I'm going to abbreviate this. Distributive property. That was the first step we applied in solving this equation. The second step was done right over here, and this is when we added 2k, so this is simply called the addition property. Again, I'm abbreviating. The third step we did was right over here where we subtracted 8 on both sides. So this is simply called the subtraction property. And then the final step we did was right over here, and this is where we divided both sides by -2. So this is simply called the division property. Division property. And there, justification is completed. The trick to doing these is just follow your steps one by one. Be organized, because that really does make a huge difference. Now to check the answer. The checking of the answer involves taking your answer, which is -1. That's what you're claiming is the correct solution for your k. You're going to take that, and what you want to do is you want to replace every k that you see in the original equation with your answer. So you're claiming that k is -1. All right, then let's go ahead and make all the k's in the original equation. Let's make each of them a -1. So that one and that one. We'll turn those into -1s, and then we'll use order of operations to break it down and see what we get. Okay, here we go. So look at the right side. I'll do it there. This becomes -4 times -1 minus 2. And on the right side, we have -2 times -1 minus 5. A common mistake is when doing an answer check, some students tend to go back to the original equation and solve it all over again. You don't want to do that. The purpose of checking your solution is to see if the answer you already got, which is this, is the right one or not. And so to find this out, you have to go back and replace all the variables with the value that you claim is the right answer. So that's what I've done over here, okay? Where I put the arrows right there and right there, these are the former k's, okay? They used to be the k's, now they're the -1s. And now I go ahead and use whatever skills I picked up from order of operations to break this down. So I go in the parentheses and I put these together, and I get -4 times -3, which is positive 12. Okay. On the right side, I have -2, and these two together will make a -6. And look at that, -2 times -6, positive 12. Now, what does that mean? Well, what it means is this. When I put in my answer, -1, here and there under the green arrows, what it did was it took the left side and right side of the equation and it turned both of those sides into the same value, which was the number 12. And all this means is that my answer, -1, was the correct one. It was the right answer. And it's because of that answer that I was able to get what looks like a reflexive property here, 12 equals 12. If they weren't matching, what that would mean is that my answer, -1, was the wrong solution. Either that or the way I checked my answer was incorrect somewhere, and I'd have to go back and spot the mistake. Okay, so there you go, solving, justifying, and checking. Number 6, solve the equation and then explain how many solutions there are and how you know this. Well, there's nothing magical about this. The first thing you have to do is you do have to solve it. So let's go ahead and jump right into that first. So from the last example, hopefully you already have a heads up on what I'm supposed to do here. So you're supposed to distribute everywhere you can, and also combine like terms anywhere you can. And so what you get by doing this would be 8k plus 40 minus 6k plus 42. And on the right side, when you combine these two like terms, you get positive 2k. Now you want to look for opportunities to combine like terms whenever and wherever possible. It just so happens I have a like term there, there. Those two will go together, okay? I also have two like terms right over here and right over there. So keeping those things in mind, I can try to do several things at once. The 8k minus 6k will make a 2k, and the 40 plus 42 makes 82. And on the right side we have 2k. So again, you want to join the variables on one side. It doesn't matter which side it is, but you want to play this smart. So if you were to move this 2k from the right side to the left side, you would be left with nothing on the right side except a 0, which you would have to write because you can't have a blank nothingness on one side. The problem with that is you would be adding one extra unnecessary step. So the smarter thing to do in this case would be to move the 2k from the left side to the right side. So I will do that by doing the inverse operation, which is the subtraction property. That eliminates that, but look at this. It also eliminates the right side. And so, I'm left with nothing, which translates into a 0 in math talk. So I have 82 is equal to 0. And I need to stop a moment and think about what this means. So I started with an equation that had k's, a bunch of k's in them. But as I went through the process of solving, the k's disappeared. And it happened right at this step. Now that was supposed to happen. That's not a mistake. When the variable disappears, you have to then look at what you're left with. And you have to think about whether or not this makes sense. This is claiming that the number 82 is the exact same thing as saying 0. So if you have $82, it's like saying you have no money at all. Not a big deal. We know that is not true at all. And so what we have to do is take this and change an equal sign into no equal sign. And the way to do that is to say, well, because 82 is not the same thing as 0, because the variable is gone, and I cannot write k equals something, I therefore have an equation with absolutely no solution. And so my answer to this is that there is no answer. And the way I write that answer is like this. Hopefully I'm not confusing you too much, but the answer is no solution because 82 is not equal to 0. The two things are obviously different numbers. So when you have no variable, you killed it off and you're left with a statement that makes absolutely no sense. Like in this case, 82 is equal to 0. That means that there is no solution. All right, moving on to the next one. Number 7. This is an interesting name. Lydia plans to attend a concert tonight and would like to take some friends. The fee to order tickets online is $10 and tickets are $25 each. This right away is important information for me to know. The fee to order online tickets is $10. Each ticket is $25. And look at this. So she has $100 to spend, and knowing these three facts, the focus question is, what are the possible number of friends she can take? Okay. Now, in part A, what I need to do is take what I know and write an inequality and then solve it. So the best way to do this is to start with the first piece of information, which is the online fee, which is $10. Okay, so it's going to cost her $10 just to order tickets. It's not the cost per ticket, it's a cost of using this online ordering ticket service. To that, we're going to add the cost of each ticket, which is $25 per ticket. And to indicate per ticket, we choose a variable since we don't know how many tickets she's actually going to buy. So we're going to use T for ticket. Okay, if you don't like that, you can always switch to another variable if you think that looks too much like a plus sign. And then, so the inequality has to show the relationship between her $100, which is her maximum spending power, and the total that she's allowed to, the total number of tickets that she's allowed to buy, that will create this total for her. Okay, so remember, it's a number of tickets that creates the grand total. And so the inequality has to say, whatever number of tickets she buys, her total, which is this, cannot be any more than $100. So it has to be either $100 or less. So I have to use less or equal to as my inequality. And now we go ahead and solve this thing. So to solve it, we use our equation solving skills. If I were to subtract 10 on both sides, I would get 25t is less or equal to 90. Then if I divide by 25, what I get is, I'm going to take it over here. What I get is t is less or equal to 3.6. I believe it's 3.6. Now, mathematically, this is a correct answer. Logically, it makes no sense because t represents, and I perhaps should have started with this, t is equal to the number of tickets, which also corresponds to the number of friends she's going to invite, okay? Now, if the answer is 3.6 or less, the problem with this logically is that you can't order 3.6 tickets. How do you buy that? Or how do you invite 3.6 people to go with you anywhere? It doesn't make sense logically. So mathematically, we are taught when you have a number like this, you round it up and you make it 4. But if you make this a 4, if you make that a 4, the problem with that is that Lydia would not be able to afford to buy 4 tickets because she only has $100. So keeping that $100 limit in mind, we have to actually round this thing down. And, whoops, got rid of that. We have to round this down. And so what this does become instead is t is less or equal to 3. Now, to make sense of this answer, we have to go back to what t represents. T represents a number of tickets. So this means that Illyria can invite, okay, and since part B is explain the meaning of your answer, we're talking about how many friends she could invite. So she can invite either 3 friends, 2 friends, 1 friend, or you know what, if she changes her mind and decides not to invite anybody, she can go by herself and invite no friends. Friends to the concert. Okay, but if she goes above 3 friends, then she would not be able to afford it, and she might say, you know what, 4th friend, you're welcome to come along, but you're gonna have to buy your own ticket. I'm so sorry. Or I'll pay you back if you lend me the money, and I'll buy the ticket for you. So anyway, here's the answer for this this question, number 7. Right, let's move on. Next page, number 8. In number 8, we have a straight up inequality that we have to solve and then graph. The first thing that comes to my mind when I look at this is where the variable is located. This variable is on the right side. And the only reason why this is noteworthy is because when you want to graph an inequality solution, unless you have a lot of experience doing this, it's a good idea to have the variable end up on the left side. So what I'm going to do is begin to solve this the way I solve any other equation or inequality, and that would be to distribute the 8 inside. So what I get is 200 is greater or equal to 40 plus 32a. So treating this as a regular equation, I'm going to use my equation solving skills. So we're going to subtract 40 on both sides. That disappears, and I get a brand new value on the left side. This would be 160 is greater or equal to 32a. And once again, using my equation solving skills, I'm going to do the inverse of multiplication, which is there, and I'm going to divide by 32. All right, so that's gone. And what I have now is a on the right side. My inequality is right there. And this is going to be a 5. Okay, now I could go straight from here into the graph if I really know what I'm doing. What I like to do is I like to invite everyone to think about this as a question. Okay, so here's a sentence starter. If I were to say, if 5 is greater or equal to A, then what can you say about A? So if 5 is greater or equal to A, then A would have to be less or equal to, or smaller or equal to 5. Okay, it's just a reversal of that. Excuse me, that's pretty sloppy. A reversal of that statement. So I'm not changing what I'm saying, I'm simply changing how it's being said. And the reason you want to go by this one is because the variable being on the left makes it easier for us to comprehend what this is actually asking of us. This is saying, give me a number or a set of numbers. What numbers are 5 or smaller? And to answer that question is pretty simple. So numbers that are smaller than 5 would be 4, 3, 2, and everything below that. And you can also use the number 5 itself because you have this equal part right over there. Okay, so what I need to do is represent all the possible values that this A could be. So I'm going to go to my number line up here, and I'm going to go to the number 5. I'll place a closed point. That closed point represents the fact that you could use the number 5 in answering the question, what numbers are 5 or less? You close it up. And then to show in what direction the numbers get smaller, you go left. And there's your 4, 3, 2, 1, blah, 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 all the way to infinity, negative infinity, which goes that way. Okay? Any number you choose along that ray will satisfy this inequality you see here. All right, number 9. So it's more or less the same thing. However, you have to do a bit more solving. So the first thing I need to do is distribute this negative 6 inside. And that would be negative 18 plus 24a. On the right side, we have 7a minus 35. Again, we're going to solve this using our equation solving skills. So this is just going to be a juggling act. I want to take the 7a and I want to move this to the left side because it's a good idea. Based on the last example, you could see if you end up on the right side with a variable, you're going to have to switch it anyway unless you really know what you're doing. So minus 7a, that goes away. And what I get is negative 18. That's going to be plus 17a is greater than negative 35. Okay, then just continuing on here, I'm going to add 18, addition property. Add 18 right there. These go away. And I get 17a is greater than, this is going to be a negative 17. Okay, now I divide by positive 17 here and there. This becomes a 1. And then I get a is greater than negative 1. This would be my answer to graph from. So I want to graph this. Keep in mind there's no equality part here. There's no extra bar down there. So I want to leave my dot open this time. So I go to negative 1 and I leave the dot open. And this inequality solution is asking you what numbers would be greater than negative 1. So if you look over here, if you start at negative 1 and you want numbers that are greater than that, you would have to go to the right of that negative 1. And that's how you show all the possible values that make this inequality work out. All right, number 10. So in number 10, we have what's called a compound inequality, which is just a very mathy way of saying you have two inequalities and you need to solve them both. And after you solve them both, you're going to get two solutions, which you then have to graph together on a single number line. Okay, so we're going to graph this one first, followed by this one. And so here's how you do the first one. First thing I want to do is bring these down, actually. So negative 4 plus 6r greater than 56, or 12r minus 10 less than negative 130. So we're going to take care of each one the way we use our equation solving skills with everything else, okay? So first thing you want to do is you want to go ahead and do the addition property on both sides. All right, so these two cancel out, and what you get is 6r is greater than, this is going to be 60. And then, of course, you divide by a 6 on both sides. And 6 divided by 6 is 1. You're going to get as an answer over here, r is greater than 10. Okay, now if I were to graph this right now, I would have to go to the number 10, which would be right here, 10. And I'm going to put an open circle at that spot. So open circle. And again, it's open because there's no equality in my solution. It's not numbers that are 10 and bigger, it's just numbers that are bigger than 10. So if I want numbers that are bigger than 10, I would have to go this way, to the right. That's where all the numbers get bigger. Now for the other one. So inequality number 2. Addition property on both sides. Makes those go away. What I get is 12r is less than, this is going to be negative 120. And now I do the division property on both sides. And what I get as my answer is r is less than negative 10. Okay, so I need to go to negative 10, which would be right here, negative 10. And I'm going to put, again, an open circle. And the reason is there's no equality down there. I want numbers that are only smaller than negative 10, not negative 10 and then smaller. So from negative 10, I will go to the left. And I'm showing by doing this, hey, if you want numbers that are smaller than negative 10, go that way, go left of negative 10. And this is my solution and my graph representing my solution for number 10. All right, number 11. So this is also a compound inequality, but it's set up differently. And the reason for that is just because of the difference in their types. So let me go back to number 10 for a second. If you look at the graph here, everything looks very disconnected, right? That's because it is. And because it's disconnected, its name is actually a disjunction. That's the type of compound inequality this is. Disjunction, disconnected, okay? Very different from the outcome that you will see in number 11. In number 11, everything's sort of put together in one package. You know, you have, it's not separated by the word or. I'm going to bring this down here and show you what has to be done. Okay, so the first thing you want to do is you want to treat this, again, like we've done with everything else, treat this as an equation. Use your equation solving skills. So I need to isolate this k. What that means is that this 3 needs to go away. So I'm going to use the subtraction property. Now I do it there, but because there's something on the right side, the 27, I need to also do it here. And because there's something on the left side, the negative 45, I need to do it here also. So what that's going to create is, it's going to create 2 new numbers. Negative 45 minus 3 is negative 48. Now I have less than, and this negative 4k simply drops down. On the right side, 27 minus 3 is 24. Okay, now, next step is get rid of the negative 4. When you divide, which is what you have to do, because again, that's the opposite of multiplication. When you divide, again, just like within the negative 3, you do it everywhere. So you do it for the 24, you do it with the negative 48. However, this is where it gets a little interesting, and I'll explain why. So first, the new numbers. So here I get positive 12. I get just k in the center. These two become a 1. 24 divided by negative 4 is negative 6. Okay. Now, the reason I didn't write the inequalities is because I wanted to tell you something about what happened here. Whenever you divide, whenever you use the division or multiplication properties with negative numbers, what happens is the inequalities change their direction. So this was less, but it's going to become greater because I divided both sides by -4. Likewise over here, this was less, but it's going to become greater because I divided by -4 on both sides. And so what this does is it creates a really interesting solution setup where if I want to graph this thing, I would now have to break this up into two mini inequality solutions. And what I mean by that is this. I'm going to take I'm going to take this, okay, and I'm going to pull that aside right over here, and I'm going to write it as 12 greater than k. Okay, that's what you see over there, 12 greater than k. But I want to write this, I want to think about this as an if-then conditional statement. So if, again, I want to graph this thing. So if 12 is a number that's greater than k, then, and here's where you rewrite this whole thing, then k must be something that is less than 12. I'll say it again. So if 12 is greater than k, then k is less than 12. And the reason I want it looking like that is because I need to graph it from this form, where the variable is on the left side. Okay? For the other one, which is, I'll get rid of this for now. For the other one, which would be this, for that one, everything's already set up to go. The variable's on the left, the value's on the right, and all I have to do is graph it from looking at that. So if I go up to my number line, the first thing that I want to do is graph k less than 12, or all numbers that are smaller than 12. So 12 is right over here, and I'm going to put an open dot since there's no equality. -6 would be right over here at the far left side, and I'm going to put an open dot there as well since there's no equality. What this is saying is, if you want numbers that are smaller than -6, while at the same time, excuse me, let me say that again. If you want numbers that are greater than -6, while at the same time being smaller than 12, what you get is this: greater than -6, smaller than 12, bam, in the middle they meet, and what you have is a graph that is connected. And for that reason, this is called a conjunction, because they're connected from end to end. And this is the second type of compound inequality. So zooming out over here, you can see by contrast, we have disjunction, conjunction, two very different looking graphs. Usually a giveaway for disjunctions is the word or. Or usually indicates you're going to have opposing directions in your graph, one going to the right, one side going to the left. Whereas with a conjunction, the word that you might see sometimes is and, as in the answers to this inequality are between -6 and +12. Of course, in this one we don't have the word and, but it still does apply. All right, number 12. So we're going to solve this inequality, another inequality, but this is now an absolute value inequality. And there are many tricks to doing this. Memorization is not something that I usually recommend, just because it's better to understand the concept. So I'm going to try to deliver it in that way. So hopefully it works for you. The first thing you want to do is eliminate any value, any number that is beyond those absolute value bars. Anything outside of it needs to be removed. And you can see over here I have a 3 over here on the left side. I have a 3. This 3 needs to go. And the way you make it disappear is by using your equation solving skills. This 3 is multiplying against this entire group. And even though it's multiplying, we cannot actually distribute inside. We cannot do that. And the reason is because absolute values are like impenetrable walls. They are infinitely tall, infinitely deep, and infinitely wide. There's just no way to break through that thing. So you cannot multiply into it, nor can you take anything from inside and just pull it out like this. This would be completely wrong. Okay? Wrong. You don't want to do that either. So how do you solve this then? If you cannot multiply into it. You can't pull anything out of it. The trick is to unlock it. And when I say that, this is what I mean. Going back to the 3 over here, you want to do the opposite of multiplication and divide. Okay, so the 2 3's divide and become a 1. I'm going to rewrite this so it's easier to track what's going on. So now I have the absolute value of 3p minus 6 is greater or equal to 63 divided by 3 would be 21. Now, what this is saying is this. It's saying, if you focus over here, this is really saying what number is 21 steps or more away from 0. So if you think about that, I'll say it again. It's asking what number, which is inside the green circle, what number is 21 steps or more away from 0? Well, if you're trying to get away from 21, if you're trying to get away from 0 and you want to be 21 steps or more away from that, visualize this. Here's 0, here's 21, right? That's the closest you can get. You cannot get any closer than that. So if you want to be 21 steps or more away from 0, you'd have to go that way. And likewise on the opposite side, because you can be on 2 different sides of 0. So on the opposite side, if you want to be no closer than 21 steps from 0, right? 21 steps or more away. From negative 21, you'd have to go this way. That's the only way that you can be 21 steps or more away from 0. So with this graph in mind, this is not necessarily the graph of the answer, but with this graph in mind, I need to build 2 inequalities. One will say, you know what? 3p minus 6 will give me something that is negative 21 or farther away. Okay, notice that this is like an arrow right here. This is like an arrow. It's pointing that way, just like the graph is over there. Okay, that's where it's coming from. So 3p minus 6 will give me something which is 21 steps or more away from 0. So less than negative 21. On the right side, I'm going to have the same idea. So 3p minus 6, but this time from 21, positive 21, I want to get away from 0 even more. So I'm going to go greater. Okay, I have to become greater than 21 to escape from that 0. So what I have here are 2 inequalities that now have to be solved independently. So if I were to add 6 on both sides, plus 6, and I'm going to do the same thing over here, plus 6 on both sides, the steps are exactly the same. What I get is 3p is less than negative, and this is going to be 15. Okay, I then divide by 3, and my first answer becomes p is less than negative 5. Okay, p is less than negative 5. And I'll show you what to do with that after I'm done with the right side. On the right side, speaking of that, I get 3p is greater than 27. And then dividing both sides by 3, what I get is p is greater than 9. So what I need to do with this is now go up to the graph, I need to go up to the number line. I'm going to get rid of my writing over here. And I need to represent each of these solutions independently. So I'm going to go to negative 5, and I'll switch my color first of all. So negative 5 would be, that would be about right here. Yes, this would be negative 5. And I'm going to put an open dot right there at negative 5. Now this says, give me all numbers that are smaller than negative 5. So going back up here, that means going to the left of negative 5. Okay? The other one says, give me all numbers that are bigger than 9. So I have to go to 9, which would be right over here. Open circle. And numbers that are greater than 9 go this way. Okay, so there's my graph for number 12. So this is if you remember from the previous examples, this would be called a disjunction because everything is disconnected here. Okay? Number 13. In number 13, we don't have an inequality. We have just a regular equation. So we're going to invoke our equation solving skills. A temptation is to add 6 and 7 and make 13. That, right off the bat, is wrong. You don't want to do that. The reason you don't want to do that is because this 7 is multiplying against this entire group. And although you cannot distribute it inside, you cannot do that, it's still multiplying anyway. It's like a hopeful romantic, you know. I wish I could multiply inside, but because I can't, I'm just going to stay next to the bar. So what we want to do is you want to get rid of that 7. You want to get rid of the 6. And the 6 goes first. So we're going to use the subtraction property here and use it there. This goes away, and what you're left with is, I'll just stick to the same color. What you're left with is 7 times the absolute value of 2n minus 7. Okay? And then on the right side you get, this would be 49. Now, I want to get rid of that 7. So the way to do that is by dividing it out. So divide 7. This goes away. And now what I'm left with is just the absolute value, which is good because now I can just focus on just this. This is 7. So absolute value has to do with distance from 0. So you want to think of it this way. You want to think, what number is 7 steps away from 0? What numbers are 7 steps away from 0? Well, on a number line, if I were to start at 0 and go 1, 2, 3, 4, 5, 6, 7, I'd be at the number 7. But a number line has 2 directions. So if I were to go the other way, 1, 2, 3, 4, 5, 6, 7, I'd be at negative 7. And the question, what numbers are 7 steps from 0, are both 7 and negative 7. What I need to figure out is, all right, so what does that need to be so that everything inside becomes a 7 or everything inside becomes a negative 7 or a positive 7. So I need to solve this thing. And I'm going to solve it by splitting it into 2 mini equations. The first one will say, all right, 2n minus 7, I need you to become a negative 7. So tell me, what does n have to be to make you a negative 7? The right side will say, 2n minus 7, I need you to become a positive 7. So n, what do you need to be to make that a positive 7? So we're going to use our equation solving skills again for this. Adding 7 to both sides makes this go away, and I get a 0 on the right side, which I do need to write. Always have something on the right side and left side. So 0 to n. And then you divide by 2, and the answer becomes n is equal to 0. Okay, that's your first answer. There's a second one coming up, and it has to come from the other mini equation. So by adding 7 to both sides here, what I get, that goes away. What I get is 2n is equal to 14. Then when I divide by 2 here and there, what I get is my second answer, which is n is equal to 7. Okay, so those are both my answers, and I need to indicate both of them are my answers. If I only put 0 or I only put 7 and I don't include the other one, then I'm not being quite fair to its partner, am I? So I need to say, I need to understand that the distance from 0 is bidirectional. You can be on the right side and left side, and that's why, because you have 2 directions, you have to have 2 answers for this particular equation. There are some exceptions, but I'm not going to go into that at this moment. Number 14. Number 14, again, similar topic to the last question. I'm going to go ahead and start by creating my division here. I like doing that. And then I also want to put a -1 right there. The reason I like doing that is more for the sake of the viewer and just some students like to see that there's an actual number to look at, not this mystery negative that's floating around. This is an actual -1, and it is multiplying against this group. By now, you should know that you cannot simply distribute this thing inside, okay? So what I want to do first, after putting the 1, is I want to get rid of this -2. Not because it's bothering me, but because this is what you have to do. You have to eliminate anything beyond the absolute value signs. So addition property will quickly take care of that. This becomes a 63. On the left side, I bring everything down. So negative, absolute value, -3 minus 10x, absolute value. And this negative, I should put the -1 there. This -1 that you see is multiplying, as I've already said. So to get rid of that, you have to divide, since that's the opposite of multiplying. So the -ones disappear. I'm left with the absolute value of -3 minus 10x is equal to, and on the right side, I get -63. Now, right away, I know I need to slow down before I jump into solving this thing, like I did the last question, number 13. I see something that makes me stop in my tracks, and that's that -63. If you've been paying attention, then you might remember absolute value has to do with the distance away from 0. The distance away from 0. Distance is always a positive value. We don't measure distances to anything with negative numbers. So this -63 being there, this is telling me that I am -63 spaces away from 0. And that right there is a problem, because you cannot be -63 spaces away from anything. I could be 63 spaces away, but I don't know how to be -63 spaces away. It just does not exist. It's not realistic. So whenever you're in a situation like this, where you have a negative value on the right side, and there's nothing left on the left side to change that negative into a positive, what you're left with is a no solution answer. There is no solution to this. Okay? I'm going to write it this way. 1 can't be -63 spaces from 0. Okay? Not 1 as in the number 1, but 1 as in anyone or anything. Nothing can be negative spaces from anything. All right, that's number 14. Number 15, final question. So I'm going to begin doing this the way I always did. And you might be thinking at this point, oh, I know what it's going to be. It's going to be no solution. Because look, I see this. Well, that is a good way to look ahead. Although what I recommend doing is, rather than jumping right into that from the beginning, begin to solve it, because sometimes what happens is something from the left side might change this negative into a positive. And if that happens, then hey, you're still in business. So I'm going to begin solving this the way I always do. So I'm going to use the subtraction property. -3, -3. Okay, these two 3's, they eliminate. And what I get, I'm going to zoom out here a bit. What I get is I have a -1 over here. So -1, just like before, and it's multiplying. So what I have now is I have -1 times the absolute value of 9 plus 3m is equal to, and this is -12. Okay, now again, be careful not to jump right into saying no solution, because if you're careful to notice, there's a -1 that's kind of sneakily staying by the side, and we have to take care of that -1. In fact, that's the next step, which is to divide the -1 on both sides. So here we go, divide -1. Okay, so on the left side, we get still the absolute value of 9 plus 3m. But on the right side, look at this. On the right side, the -12 divided by -1 makes a 12, positive 12. And because it changed to positive, we are still in business. We can continue solving this, which is why it was good that I waited instead of jumping right into saying no solution. So now what I want to do is I want to think to myself, okay, so what number is 12 steps away from 0? So what numbers can be 12 steps away from 0? Well, if I think about the number 0 on a number line, right? So here's 0, and I go 12 spaces out to the right, I would stop at the number 12. And if I go 12 spaces to the left of 0, I stop at negative 12. So what I need to do is build two equations from that line of thinking. So my first equation is going to say 9 plus 3m, okay, is equal to negative 12. I want to figure out, all right, m, what would you have to be so that everything here becomes a negative 12? Because negative 12 is 12 spaces away. Likewise, I have to build a secondary equation, which says 9 plus 3m is equal to positive 12, with the same logic. So m, what would you need to be so that everything here has to become a 12? Okay, because 12 is also 12 spaces from 0. And then I go ahead and begin the solving process. So this would be, I think I switched to yellow here. So I'm going to use a subtraction property right there. 9s cancel out. I get a 3m is equal to, this is going to be negative 21. Okay, and then when I divide by 3 on both sides, what I get is m is equal to negative 7. So first answer, if you want everything inside this absolute value to become negative 12, which is what I have right over here, then what you need to do is make m into a negative 7. That's going to turn it into a negative 12. Okay, second answer. Switching my color here. Again, subtraction property on both sides. This goes away, and we get 3m is equal to, that's going to be positive 3. Then, when I divide by 3 on both sides, what I get is my final answer, which is m is equal to a 1. So if you want whatever's in the absolute value, which is right over here, if you want this to become a 12, you'd have to make that m into a 1. If you want this to become a negative 12, you'd have to make this into a negative 7. Okay? And 12 and negative 12 are each 12 steps away from 0. And that's why I need to represent both my answers. Okay? And with that, we're done. So I hope this helped. There's a lot of information here, so please take your time to review everything. Feel free to rewind, play it back. Your comments are always welcome because I use them to help improve what I do. And so please leave a constructive comment. It would be greatly appreciated. Thanks for taking the time to watch. It's always appreciated, and you have a great day.